Today, we're diving into a super exciting and somewhat alarming discovery in the world of space and science. Our topic: a new and troubling way big ice sheets are melting. I've got the scoop from a recent study, and I'm going to break it down for you in a way that's easy to understand. Scientists have identified a new and worrying way that large ice sheets are melting. This research focuses on how relatively warm seawater can hit the bottom of the ice on land, speeding up its movement into the ocean. This process isn't currently included in models predicting sea level rise, so these new findings could offer a more accurate picture of how global warming is changing our world and how much coastal areas need to adapt. The findings, led by scientists at the British Antarctic Survey, were published in Nature Geoscience. Alex Bradley, a researcher in ice dynamics at BAS and the lead author of the new paper, says, "We've identified a potential new tipping point in the melting of the Antarctic ice sheet. This means our predictions for sea level rise might be significantly underestimated." The research focuses on an area beneath an ice sheet known as the grounding zone, where land ice meets the sea. Over time, land ice moves towards the surrounding ocean and eventually melts, a process happening along the coasts of Antarctica and Greenland, contributing significantly to sea level rise. The new study models how seawater can seep between the land and the ice sheet above, impacting regional melting, lubricating the bed, and accelerating the slide of ice into the sea. It also looks at how this process speeds up with warming water. Bradley notes, "Ice sheets are very sensitive to melting at the grounding zones. We found that a small change in ocean temperature can lead to a large increase in grounding zone melting, showing a tipping point behavior that causes a massive change in the ice flow above. This happens because melting from warm water at the grounding zone opens new gaps that allow more warm water in, causing more melting and even bigger gaps, and so on. The tipping point is reached when a small increase in water temperature has a huge effect on the amount of melting." Bradley explains that this kind of melting, which isn't currently accounted for in models used by the Intergovernmental Panel on Climate Change and others, could explain why ice sheets in Antarctica and Greenland are shrinking faster than expected. Including these new findings in such models could lead to more reliable predictions. This is a missing piece of physics in our ice sheet models. They currently don't simulate the melting underneath grounded ice properly, which we now think is happening. "We're trying to incorporate this into our models," he adds. Don't forget to subscribe and hit the notification bell. See you in the next video.